Hello, good morning, good afternoon. My name is Antonios Dimitriadis. I'm the Telco Cloud Solution Architect from Nokia in 5G Vini project. And today with my colleague Tirta Gos, we are going to present the automation network slicing. 5G Vini is a research project led by Telenor in Norway side, and then Nokia is a partner of it. Regarding the network slices, we have a dynamic environment. Currently, we use 5 slices. We have the standalone, we have non-standalone, and then we have also a distributed slice in 2 different sites for the defense. But in the future, we may have 10, 20, 100 slices. That's why it's really, really important to automate that part. And since we templatize the whole slice, it will be very easy to take the same instance and then deploy it in another site using, of course, the different environmental parameters. The biggest challenge that we had so far, because this is a multi-vendor ecosystem, is about the interfaces. Regarding the orchestration, we have different components from several vendors that they need to talk to each other. So when we talk about the network slice, we don't talk about VNF onboarding only, but we need to create the networks through the SDN, in our case, NUAD, or through the physical network devices. We need to apply the policies in the firewall that we use. In our case, it was Palo Alto, so we can say which VNF can talk to which VNF. And then, of course, at the end, once we have the network slice in place, the user should be able to use it. That's why we need to have also an interface to the provisioning gateway. So for some of them, we use the open standards APIs, but for most of them, we had to create proprietary plugins. That was the biggest challenge and took us quite some time, but finally we achieved the one-click deployment. And that will be the demo for today. My colleague Tita is going to show you the demo from Flow One, which is a service orchestrator, how we trigger the onboarding of this slide with 2 different network services under 2 different tenants. They cannot talk to each other by default. Then we have to create the networks in SDN, in OpenStack, and then deploy the VNFs. At the end, as I mentioned, those network services will be under 2 different tenants. So we had to allow the traffic between them. That's why we need to apply the needed configuration policies in Palo Alto. And then once we have those 2 VNFs, we should be able to ping, for example, to communicate from VNF1 to VNF2, but from VNF2 to VNF1 will not be possible because this is what we requested in the firewall. So my colleague Tita is going to run the demo, and then at the end, we will come to see the whole test.
On screen is the full stack, the NFVI, the Vim, the VNF manager, the NFV orchestrator, and the end-to-end service orchestrator. BSS is not part of this demo. Further, the stack runs 3 columns: catalog, processes, and inventory. Navigating through system screens: NAVO catalog, end-to-end service orchestrators catalog, submit order from Swagger UI using TMF 641 specs, orchestration in end-to-end SO and NAVO. Lastly, documentation in the inventory part of things. As per the demo data, this should look like this. Uber subscribed for an eMBB slice for video on demand service for its passengers. For the slice orchestration, 2 network services, NS1 and NS2, will be deployed, and accordingly, 2 instances of a VNF will spin up. For demo purposes, the VNFs are Syros VMs. This is the NFV orchestrators catalog. This is the NST. This is the Tosca definition file of it. And among other things, this is the VNF descriptor in it. This is the delivery model from end-to-end orchestrators catalog. It is a phased approach. In the reserve phase, it fetches placement information and records order information in the inventory. In the provision phase, it triggers the NAV orchestrator to spin up network services. Once done, in the finalize phase, it fetches the network service and VNF details and documents it into its inventory, where it renders an end-to-end slice view. We will place the order. The identifier is 719. The The order is for EMBB slice and is ordered by the subscriber Uber. End-to-end orchestrator's order management and do a search. Our order is underway. All the activities are underway. Some are completed while some are started and some are planned. We now move to CBND and we see NS1 has been created. We are expecting another network service NS2. Now both NS1 and NS2 are being deployed. In the end-to-end orchestrators inventory, we can search for the subscriber Uber and extend to its topology view. So Uber has subscribed for a video on demand service for large for 1 year. That's the product, and then this is the end-to-end slice with the 719 identifier. If we drill down from here, the information is incomplete because the deployment is still going on. Once it is done, this will feed more information into the end-to-end orchestrators inventory. Deployment is done. That's how a network service looks from CBND, the VNF and the network service. And from the end-to-end orchestrator, if we do a refresh, information is still on the way. Now it has arrived. So this is the end-to-end slice with network service 1 and network service 2, each of these running a VNF. If we go up, then the end-to-end slice, Uber is the subscriber of it.
Yeah, here now we are connected to the horizon. We are in the Vim to see the two new VNFs that have been deployed. We see here the first one. It's a very, very fresh. As we see here, it's just deployed. So as we see here, it's allowed to ping from the one VNF, from the 250.0.2 to the 251.0.2, but not the vice versa. So we see here the IP, the one that we expected. And now if we ping to the second VNF, we will see that this is allowed. We see the correct IP. Now if we try to ping the first VNF, that shouldn't be allowed from the firewall. Yeah, as we see, this is not allowed. So that was a demo for today. Thank you very much. If there are questions, please come back to us through the 5G Vini project, and we are happy to provide you more information.